Hi, I'm Fred Jaeger, and welcome to my talk, Spreading Our Tentacles, Taking Our Django App Global. Now, I realize this is a bit of a weird name, but I promise it'll all make sense soon. Now, this is me. I'm a passionate rugby player, but perhaps a bit average in skill, but someone managed to get a good picture of me, so well done them. This is also me on the day when I graduated from my PhD in physics. So I did a PhD in computational physics where I researched how you can use graphene membranes to help with water desalination. And then finally, this is developer me, or lockdown at my parents' developer me. So it's not my most professional setup, but that's what I had to make do with for much of the past year. So after I left academia 3 years ago, I went into the software engineering world, and I haven't really looked back since. I love it, and it's led me here. So I think I've done pretty well for myself. So I work for the Octopus Energy Group. So the Octopus Energy Group is original from the UK, where we had a small energy supplier dealing in renewables, and since then it's grown a lot. Not only the energy supplier, but the business as well. So we still have the energy supplier for domestic use, but also for businesses. We've done quite a lot in the electric vehicle space. We have our own metering business, and then there's also Kraken Technologies, which is the tech branch of the Octopus Energy Group. We've also recently invested a lot in renewables. For example, you can see our pride and joy, the #1 fan, the first wind turbine that we purchased. We've also got something that we call the fan club, which is basically special deals for the community living near the #1 fan, which we've done because we care about the community, but also a little bit because the #1 fan has to have a fan club. Now, I work for Kraken Technologies. So as I said, that's kind of the tech branch of the Octopus Energy Group, and we have a product called Kraken. Now, Kraken is a customer management and billing system that's used by energy suppliers. So we deal with anything from the integration with the energy industry, taking meter readings, doing the billing, taking payments, sending out comms, and also managing all customer contact between customer service operatives and the customer itself. This is just a screenshot of what it looks like, or a fake account for the Duck family, just so that you know what I'm talking about. So you can picture this when I talk about Kraken. Now, as the Octopus Energy Group, our goal is to combat climate change. Now, this seems like a pretty ambitious goal, and you might wonder, where does a billing platform for the energy industry come into this? But I'll explain that. As David Attenborough said, we should stop all the damaging stuff and roll out the new green tech. So we want to be part of that new green tech. Now, for those of you who don't know who David Attenborough is, he is basically the voice of nature documentaries in the UK, and he's a big advocate for climate change. So we should listen to him. Now, how does new green tech look like in this context of the billing system? In order to explain that, I need to first of all give you a bit of a 101 on the energy industry and how it works. Now, on the left-hand side, you can see energy sources. So for example, you can see your solar energy, your wind energy, so the renewable sources, then the more traditional sources like coal or also nuclear. And all of these sources produce energy, which then goes onto the grid. This might look a bit different between countries, but in general, this is how it works. Now, the grid takes the energy from the source and then distributes it to the consumers, which you can see on the right-hand side. Now, something key to say, which might not be obvious, is that as a consumer, you don't know where your energy came from. You just take it in the grid. It basically all gets mixed up in the grid. Now, there's another aspect here, which I'm not going to talk about, which is where consumers can put energy back onto the grid, which might be, for example, if you have solar panels on your house and you don't use all the energy yourself, or if you have an electric car that you can use as battery, which releases energy onto the grid. And there's lots of really cool stuff in that space, but I'm not going to talk about it today. There's already so much to talk about. Now, if we have the goal of making sure that more and more people use green energy and it becomes dominant as a source for energy, we need to tackle a few challenges that arise from that. So one of them is that when the demand is high, we have to usually rely on the dirty or the more traditional energy. That's because it's just a more reliable source, and there might not be enough green energy available at the time. The other problem is that there might be too much green energy on the grid. Now that's a bit counterintuitive, but there can be such a thing as too much of a good thing. This is because when there's too much energy on the grid is overloaded and it doesn't know how to handle all this energy. And what normally happens in that situation is that the wind turbine, for example, if it's really windy, is going to get turned off. And not only is that really, really expensive, it costs millions of pounds, it's also obviously the opposite of what you want to do. You want to use the green energy when it's there. Now, our way of tackling this is smart tariffs. Now, for smart tariffs, you need what's called a smart meter. And if you don't know what that is, I think they're not necessarily well known in all the countries. I'm going to give you a very brief overview. Now, if you have a traditional meter, what happens if you need to have a reading is either you look at it yourself, so you take a reading, you go to your meter, you look it up, you tell your energy supply about your reading, or you have to have a meter reader come around who does the same thing for you. So for example, my parents, they have a meter reader come around once a year, which means they get an accurate bill once a year, and the rest of the time they're just going to bill to estimates. Now, smart meters can basically take the reading for you because they're smart. That means you never have to actually look at the meter and send a reading to your energy supplier. They can just get it directly from the meter. Another interesting thing is that they can get your readings at much more regular intervals. So for example, smart meters in the UK get readings every 30 minutes. In Australia, they can get readings every 5 minutes. So that's really, really granular. And this means that not only you know your usage, so you can actually see, oh, I'm using a lot of energy normally in the morning or in the evening after work. But also we can use that to charge you different amounts at different times, depending on how much the energy should be worth. And this is what we're doing quite a lot, and where we're hoping to address those challenges that I mentioned previously. So at Octopus Energy, we have two smart tariffs, or two groups of smart tariffs. One of them is called Octopus Energy Go, and this is one that's aimed at drivers of electric cars. So here you have a period of 4 hours overnight where energy is really cheap. This means that you can just use that time to charge your electric car, and it means it's a lot cheaper for you to have an electric car, and then you don't do it during peak hours. So you don't do it after work, you do it overnight, and it's cheap, and it's a great deal if you have an electric car. The other one, and this is a really cool one, is the Agile tariff. So the Agile tariff has different rates every half hour because it's in the UK where smart meters give us readings every 30 minutes. And these rates track the wholesale prices. So that means when it's cheap for us as a supplier to buy energy, we'll make it cheap for you to use. And if it's expensive, we'll make it more expensive for you to use. So if you look at the graphs there, you can see that there's the nice peak after work. When people come up from work, that's always when energy is expensive, which is why it's expensive for Agile users to use. But the rest of the time, it can be cheaper. Now, the cool thing is that it not only is cheaper at certain times of the day, but it could also be that you're being paid to use energy at certain times of the day. So these are what we call plunge pricing events. And this is when we have that scenario that I described earlier, where there's a lot of energy on the grid and we need people to use it. And that's when we're paying the customer to use the energy because we want to get it off it. And we're giving customers this financial incentives to actually use all that energy that's there that's otherwise not being used. I have an example here of a bill for a customer for a single day where this kind of thing happened. So this would have been where maybe there was a lot of wind. I doubt there was a lot of sunshine because this is from December, so it's probably wind. And you can see here on this bill the different rates. So I'm just going to highlight here the rates which are negative, and negative means that we paid the customer to use energy in that period. So here's a 2-hour period overnight where we paid the customer. And then there's also actually quite low rates before that, so also not a bad year. Now, if you look at the customer's usage at the top in that graph, you can see those dark bars, and that's the customer's usage, whereas the pink lines are the rates. And then you can see that this customer has really switched their usage to that time period because they knew they were being paid to use energy then. So there's obviously some other usage throughout the day, but a lot of it was moved to that period. And then if you look at the total cost for that customer for that day, is actually negative. So the customer was paid to use energy that day. So this is really a win-win because the customer gets a great deal. They get paid to use energy. You can say that. And also we're helping getting the energy off the grid when it needs to be taken off. Another cool thing you can do with tariffs like that is that we're making the usage and the rates available to the customer via an API. And some of our customers have built apps for this where you can track the rates and you can see graphs. They've built other tools where you can set devices to use energy at a certain time when the rates are below a certain level, and really interesting things like that. And we have a really vibrant online community of people using this tariff, which is really quite new. And there's so much engagement there, and people are really interested in this, which is really nice to see. Now, if we're coming back to those challenges that I described earlier, so one of them being that when the demand is high, we're having to use the more traditional energy sources, and the other one being that there could be too much green energy on the grid, we've actually addressed both of them with smart tariffs like this. So one thing is that we're encouraging people to switch their usage away from peak hours so that they can actually use energy during times when there is green energy on the grid, rather than just having to use the more reliable dirty energy. The other thing is that we're paying customers to use energy when there's too much energy on the grid, and this has actually worked. We've had feedback from the industry in the UK that actually our customers have really helped out with this problem. So we've addressed both of these, which is pretty cool. And this is where we get to NTech, because tariffs like this don't just happen. So with the more out of the box energy software that's out there, you can't just easily implement a tariff like that. It takes more work, and obviously with bigger companies, this will always take time, because traditionally bigger companies iterate very slowly, whereas we're people, we move fast. We like building new features, and something like this where we really see a value in it, we build it very quickly. So for example, Agile, we built in a few weeks. So all of our customer interaction, including the billing, so including the bit that handles the tariffs and everything else around it, as I explained, is all within Kraken. And Kraken is just one big Django app, basically. So we use Django for that view that I showed you, that customer page that's built using Django views and templates, for some of our APIs, for the database storage and interacting with the database, for everything really. As it's just one big app, it actually all lives in one big repository. And when I say big, I do mean big. So we have over 100,000 commits. We had the anniversary just last week. We've got about 30,000 merge pull requests and more than 1 million lines of code, and that's just Python code. So I'm sure there's a lot more. I only counted Python code for this purpose. We do continuous deployment. So that means that we deploy a new version of Kraken several times a day. So every time a pull request is merged, a new version of Kraken goes out. And at the moment, we merge maybe 50 pull requests a day, but the numbers are steadily going up. Obviously, to make sure that we're not breaking anything, we have to run a lot of tests. So for example, we have 24,000 Python tests that we run every time a pull request is merged, just to give us that bit of security to make sure that we're not breaking anything if we change something so regularly. We also have a lot of linting. So the day we introduced Black was probably my favorite day, because now everything is nice and neat and everything looks the same, and there's clear standards of what to use. We also have Flag 8 for some additional Python linting. We started using typing a lot once the code base got bigger, and use MyPy for that. And we also have a lot of conventions, so you can look up some of our conventions online as well. We have lots of rules about things, but if you're working on a really big project, like a big Django app like this, you need to have rules. Now, the last year and a bit now, have been pretty big for the Octopus Energy Group. Not only have we expanded as an energy supplier, so we've entered the market in different countries like Germany, the US, Japan, and New Zealand. We've also licensed Kraken, our platform, to existing energy suppliers. So 2 in the UK, including E.ON, who are a very big supplier, and also Origin in Australia. And with that came quite a bit of investment, so that we've actually reached double unicorn status after less than 5 years of even existing, which is pretty neat. So we went from, in 2016, when we started, having one single Kraken instance just in the UK for the UK's energy supplier, to now having 9, running in different countries, both for our own energy supply businesses, but also for clients who license Kraken. as a platform to use for their own business. Now, just to show you how far we've gone really in the world, these are the places where we're starting completely from scratch, either as our own business or supporting another business with 0 customers, and then building up the customer base from Kraken from the start. And then these are the places where we have an existing customer base and we're moving them onto Kraken to continue to grow the business. And obviously then there's the money aspect, which will help us actually do that, because you do need support. You need more developers. The more countries you reach, the more developers you need to support that. Now, obviously, our reaction to this was a bit like that. It's pretty neat to see people believe in our mission and believe in our product, and being able to do more with it, because the more investment you have, the more you can do, and the more you can actually realize your vision of it. But not gonna lie, there was a little bit of this because it's pretty daunting. It's a big deal. So if I go back to what Kraken covers, I've just shown you how many different countries we've expanded to and the different new clients that we've got. Out of these things, most of them are specific to either the country that you operate in or the client itself. So the industry is obviously different in different countries. The communications might go out differently. The payment systems are different. The taxes are different. So there's so many things that are different, either depending on your client or depending on the territory or the country where you operate. So there's a lot of challenges in that. So I'm going to talk you through how we're supporting that and how we're doing it. First, by talking about how we're getting customers onto the platform. Then this is the main bit, how we're making Kraken work for all these different places while still keeping it in one single Django app. And then also how we're supporting our clients and improving their customer experience. Now, every time we set up a new Kraken, we start out with what we call a baby Kraken, which just has the basics in it. So it has a few things that you need for example, the permissions and roles for customer service operatives and things like that. But it's basically brand new. And then there's 2 ways of getting customers on it. One of them is organic growth. So when you just acquire new customers organically, or the other one is customer migrations, where you merge them over from an existing system. Organic growth is obviously quite a slow process. You'll start up with a friendly account and then you slowly add more, but you have a lot of time to kind of make sure everything works, because you don't have very many customers to start with. With customer migrations, it's a bit different, because you start up with a few test accounts to make sure that your migration works, but then you can actually just migrate them over very quickly, because there's nothing stopping you from it. If it works, it works. And we're actually doing that in several places around the world at the moment, and quite quickly. So it really is quite a quick process, but it does present some challenges. Now, obviously, the direct sign-up route is important, but the customer migrations one is a bit more interesting from a technical point of view. So I'm going to talk about that a little bit. Now, we have a quote here from the CEO of Eon UK, talking about the migration that we've recently done with them in the UK. And it's actually really interesting to see how many people from the industry actually saying how fast we're doing it. So I personally work on migrations, and I never really realized how big a deal it was until I spoke to some people from the industry, because for us it was always pretty easy, and I don't mean that in a braggy way. It's just we just did our job and it seemed to work fine. But apparently it's pretty well received, which is always nice to hear. So for our migration approach, we use the Django REST framework to create some APIs to facilitate migrations. And I'm going to talk a bit about what kind of APIs we use and what the general process is also for extending these. Now, the general idea is that we take some JSON data and then we turn that into an account in Kraken. The important thing here is that you need to make sure that an account can live on in Kraken as it had before. So the customer shouldn't really notice that they switched to a different system. Obviously, the important bits are the financial aspect. So you need to make sure you don't double bill a customer or double charge a customer and things like that. But you also want to have enough history there so that when this customer calls with a problem, the customer service operative can just respond and has all the information that they need. So these are kind of the key things that you have to make sure you do right when you do a migration. As I said, we use some APIs to facilitate that. And I'm going to explain a little bit what they all do and the process that we have in place. So first of all, we have a validation API. And this is an API that we make available to our clients to send the data to and just to validate if it's valid or not. And we don't really care how many errors they get. They can just use it as much as they want, send the data there, and they can use it for their data cleansing or make sure that they have the right customer groups. And our validation is very thorough. So if an account passes validation in this API, it should be good to go. The next stage is where we're saving that data, that validated data, to a staging table. Now, one of the reasons why we have this staging table, this kind of intermediate stage, is because it gives you the opportunity to update the data before actually creating an account. If you had another payment come in that you want to make sure comes across into Kraken, for example. But it also means that we can track the migration better. So not only can we track how many accounts we've created, there's also sometimes some post-migration actions that might have to happen, and we can track those on that model as well. So we have that kind of staging area. And then finally, we create an account from that data that we have in the staging area. And that should be a pretty smooth process because we've done all that validation. And then it should just be a single step to actually create that account. Now, just to give you an idea of what that data looks like, it often corresponds quite closely to the models that we have in our database. So for example, you'd have the billing name field on the model, so you're also asking for it in the migration data. But sometimes there is a bit of transformation that has to happen. So for example, we'll collect some data in pounds, but we save it in a database in pence. So it's not a direct one-to-one mapping. With foreign keys, we just convert them into lists, basically. So if you have a foreign key between the user and the account, you then have a list of users that you have in the input data. So that bit is pretty simple on the whole. Validation, as I said, is a key element of it. And there's several aspects to it. You have to make sure that the data is actually valid from the database point of view. So does it conform to the models? And also, is it valid from a business logic point of view? So we use Django REST framework serializers for this, but we don't really use model serializers. And that's partly because, as I said, sometimes it doesn't correspond exactly. For example, the pence and pounds issue. Sometimes we want to set some kind of default value, and sometimes you can just not represent how we save it in the database in the same way in the migration data. So some things, particular to do with transactions and the financial side of it, there's just no one-to-one mapping. But we do try to make sure that for example, the max length of a char field is obeyed in the same way, and things like that. Our main validation actually comes in custom validate methods that we write. So that's where normally all the business logic lives. So important things like, again, the financial side. If we get some transactions, then we need to make sure that the balances all match up, things like that. That just we have all the information that we need for the account to live on in Kraken. And that's where this validation comes in. Like, do we have all the right dates? Do we have all the right readings and things like that? And there's some pretty complex validation methods in there, but that's what we really need to make sure the account goes on and to make sure that we don't have any problems when we are actually going to create the account. Now, something nice is that as a client, we have the base required fields that we need to make an account live on in Kraken. So that's the main thing. This is everything you need. Then the account will live on in Kraken. We'll have all the right balances. It'll go smoothly. But you can also add on lots of optional things to make the account richer. So have a richer history. So add notes, for example, or previous statements, debt history. It could just be the payment history. There's no requirement to migrate it, but you can, and it'll help your customer service operators looking at it. Looking at the account, they'll have a much clearer picture of what the account looks like and can answer queries better, but it's not required. We do make sure everything that you need is there, but other things you can just add on. along the same line, we can just add new features in. So we have the basis, we know what we need, but if as a client you need more, if a client comes to us and says, actually, we'd quite like to have this information in Kraken as well, because it's something that we want to see on an account, it's pretty easy for us to add it. So as you saw, we use our serializers. You just add new items to the serializers, and obviously to the docs. And then we just need to add a function to a use case to actually add that bit of data and save it in the database, and out comes the account with a new feature. So we do that quite regularly, and the migration API has grown a lot to have more and more features and collect more data. But as I said, a lot of it is optional because you don't have to have it. The account doesn't need it. But it's always nice to add more features on, and we can be quite flexible on it because we iterate quickly. And we do that continuous deployment, and that's our ethos. So we update it quite regularly. Another nice thing is, and I think this is a big part of why it goes so smoothly, is that we have that single defined payload that we've decided on. And this means that once the accounts get into Kraken, so once we have the payload, it's all the same. It doesn't matter what source system it comes from. And even on the source side, you just have to do the mapping once. You have to understand what each field represents once. And once you've worked that out, you can generate the payload for every account. So this means we can do migrations from different source systems into the same instance of Kraken, all at the same time without any problems. So we're currently doing a migration from 6 or 7 systems into Kraken. So it's pretty neat, but it just means that it's a really smooth process our end, and we don't need to worry about differences between source systems. So this, just to give you an idea of numbers, the kind of large numbers that we're migrating is about 150,000 accounts a week. So that's a pretty big number. And once you have it set up, like I said, it just runs and does its thing, which is really nice. Now I'm going to get to the bit of talking about how we customize Kraken. So I talked about how we can get client accounts into Kraken, but as I said, there's a lot of things to consider when you have different versions of Kraken, but it all lives in the same Django app. The way we think about these is with the concept of plugins. So you have the core of Kraken, so you have the core Kraken code, and then you have all these other bits that might be different that plug into the main code. In order to explain where they fit in and how we do that in practice, I need to talk about the core a little bit and about how that's organized and structured. So this is the kind of layers that we have in our code base. And the idea is that the lower layer doesn't know about the upper layer. So the lower layer never calls the upper layer. Instead, you always call down. So you have your interface layer, which is basically the entry point into Kraken. So this will be from the support side or be a customer query. And this is where our views live, our APIs live, and our management commands live. Then you have the application layer, which is also sometimes called the service layer, I think. And that's where your use cases live. So these are your key unique actions that Kraken has to perform. But for the actual implementation of that, it goes to the domain layer. So this is where our database operations and our queries live, and all the business logic lives around deciding how to implement this action. And finally, the data layer just has our Django models, and we keep our models quite lean normally. So a lot of the things that for some people live on the models, for us lives in the domain code. So where do these additional bits come in? Where do these plugins come in, and how do they fit into this whole architecture? The plugins kind of sit outside of this, but feed into the domain. So within our plugins, we again have some categories. So we have the common category. So that would be for things like, let's say, a payment vendor, which operates in different countries. So it can be common across different territories, but it's not something that we want core Kraken to know about. As I said before with those layers, the idea is that a single layer doesn't really know about the exact details of the layer above. So we don't want the domain layer to know about the implementations in the plugin. So if you have a payment vendor, even though it's common, Kraken doesn't need to know about how exactly it takes a payment. Kraken just wants to say, take a payment from a payment vendor without knowing the detailed implementation. So that's why it would live in the plugin layer. Then you have the territory layer where you'd have, for example, the industry information and interaction with the industry. So that, as you can imagine, is always going to be different per territory because the industry is just organized in a completely different way. And then finally, you have the client layer, and that's where all the client-specific differences live. But just to reiterate, the domain layer should not know about the details of the plugin layer. I'm going to talk a bit about how we actually do that from a coding perspective, because it's really quite interesting. Just to set the scene a little bit, let's say we're operating in two different territories. One is Antarctica and one is Monaco. So you can imagine they are quite different. And then in Antarctica, we have one client, and in Monaco, we have two clients. So this is a pretty common picture, that you have several clients in the same territory and different territories. So we use Django configurations a lot, and we use that to define our settings for all the different Kraken instances that we have. So as always, as we also have in the plugin layers, we start with something that's common. So we have our base configuration. And in this base configurations, we'll put all the settings that are common between all the different Kraken instances, but we also define all the other settings. Because this basically helps if you have a new Kraken instance, you can just go to the base and you know which settings you need to add. So it gives you a nice view of what you do need to add, and it has all the common ones. Then you have the territory settings. So there's territory configuration, and that inherits from the base configuration. So you don't need to redefine everything that's common in the base, where you can overwrite any settings with anything that's common for the whole territory. And then finally, you have the client, and that's where all the client-specific configuration lives. And this could, for example, be a setting that defines the URL for links and things like that. So these are very specific to a client. Where this actually comes in terms of the different Kraken instances is that we deploy each Django app with different configurations, and they all have their own DB. So we have one common code base and the common Django app, but when it's deployed, they're deployed with different settings, which are defined from the configurations, and they all have their own database. One example where we can use this is installed apps. So we can always obviously have a common set of installed apps that we want to have, but there might be other apps that we need to add, for example, to do with the industry settings that might be different, and we don't want to install unnecessary apps for different Kraken installations. And this is how we use configurations to manage that. So if you can look at the installed apps property, you can see that we have a list of apps, and these are common to all in the base class. But then we also have another setting, the feature app setting that we've defined as an empty list for now, which can extend this if you want to, but you don't need to. Doing it like this and organizing it like this means that if you want to add an app in another configuration, be it a territory configuration or a client configuration, all you need to do is override the feature apps setting. So that makes it really easy because it's just one line and it's super easy to update it. But the real important thing is how we handle application code. So this is where all those layers come in that I showed you earlier. One thing that we really, really want to avoid with using Django configurations is something like this, where you have lots of if statements all over the code base saying like, if it's this brand or if it's this client, then do this. And what often tends to happen is that you have some kind of default that you fall back on because you didn't want something to break. And that default might be completely inappropriate. So if you get a new client, what you have to do is you have to find all these if statements and add a new one. And if you forget, you might fall back to a default, which is not right for this client. So that's really inefficient. It's not very nice to read, and it's also very prone to error. So this is where we want to use configuration to make it much nicer. The way we do that, I'm going to explain now. As I said before, if you have your domain layer, you don't want that to know about a specific implementation. So here I'm using the example of a print vendor. So a print vendor would be the people that we send PDFs to print and then send to a customer as letters. If we want to use the print vendor in the domain, we have to know what to expect from a print vendor, but we don't want to know the exact implementation of the print vendor. So we define a class here where we have attributes and methods, but they're not assigned any values, or they raise a not implemented error. What's useful about that is that if you implement a new print vendor for a specific client, for example, and you've forgotten to implement a method, it'll fail loudly. And we want things to fail loudly so that we, as I said, we don't fall back to any inappropriate defaults. You can then have the different print vendors in the plugins layer, which use the domain layer base print vendor as a base. So here you can see that we're in the plugins folder, and in this case in the territories folder, and we've defined the Antarctica print igloo, the print vendor for Antarctica, and we've overwritten all the things we need to overwrite. Similarly, you can have that for different clients. So it might not be the same one in a territory. So for Formula 1G, we have the faster printing vendor, and for YachtPal, we have the CEO print vendor, but they all inherit from the domain one. And that means that we define all the methods that are already defined on the base one, and we just override them. That means that the domain can use these print vendors because it knows what to expect. Now, how do we get from those print vendors in the plugin to the domain? How do we tell the domain to use them? This is where Django configurations come in again. So if you look at the configuration for Formula 1G, for example, if we add a print vendor here, a print vendor setting, we just add the code path to the actual class in the plugins layer. And then in the domain layer, we'll just have a function which grabs the print vendor from settings. So we just import it straight from the setting. And then when we want to use it, we can just get the print vendor and use it right in the code, as you can see here. And that means that the domain never actually explicitly calls plugins. It doesn't need to have any kind of if statements, because otherwise it would probably look a bit like this. And this is almost a nice version of it. It could look a lot worse, like the example I showed earlier. So this is a really neat way where we're using configurations to then in the code base decide which print vendor to use from the plugins. Another example is emails, because as you can imagine, those would be quite different between different clients. Here, once again, in the domain, we don't want to know about any specific client implementation. So we just have a function that says, use this template. But then we can have different templates for different territories or for different clients. And we do that by just pointing to different template directories in the settings. And it's not just the templates themselves. We can also define the styling in the settings as well. So you could say use the same template, but use different styling. And that all doesn't need to live in the domain, and it shouldn't live in the domain. So the domain function is nice and clean, and it just does its job and doesn't know about any of the other changes. Now, as I said before, we redeploy Kraken many, many times a day. And then I showed you how we deploy Kraken to different instances using the different configurations. To make sure that we don't accidentally break something for one of the clients, we have to have a lot of tests. And here again, we're using configurations to make sure everything runs as expected and works as expected. So this is just a sample split up of our test folders. So we have the common folder, and this is where all the tests should live for anything that's shared between all the different Kraken instances. And then you have the territory folder, where you have the tests that only apply to certain territories. And then you have your client folders, which contain the tests that are very specific to a certain client. We use PyTests, and the nice thing is that you can, if you're using Django configurations, that works really nicely with PyTest. So here you can just pass in the configuration name using the DC, so the Django configuration flag, and then you have your folder test path. So for example, for Ice Ice Energy, you'd want to run the common tests with that configuration, and the Antarctica tests, and also the Ice Ice Energy tests, of course. And this is how we build up our test suite. We run all the appropriate tests with all the appropriate configurations. And if it changes, you make someone break something for one configuration, then we'll know. And we won't deploy, obviously. So I hope I've shown you how we use Django configurations to deploy Kraken with different settings, and then we use the settings to control the plugins or pick the right plugins and control features, and how we also use it to make sure that we don't accidentally break anything and we have really wide test coverage. The final bit that I just want to talk a little bit about is how we can support clients, because we run Kraken, and Kraken does have this web app which is used by the customer service operatives, but we don't control the client's personal online accounts for each customer, for example, but we can support them. So we use GraphQL for that. We make GraphQL queries available to the client so that they can use that for their online account. And one of the reasons we use GraphQL because it's super flexible. So for those of you who don't know GraphQL, the QL stands for query language, and it was basically designed to do something like this. So to return a lot of information in a single query. There's a single endpoint. You make a query, you tell it exactly what information you want to get back, and you will get exactly that, and all in a single query. Something that's a bit different from other APIs is that you don't have explicit error handling. So if there's a problem, you can see it from the response, but not from the response code, for example. So in GraphQL, you have the concept of queries, which is basically the read operation. So that's just returning data. And that is, as I said, what it was designed to do. And then you have mutations, which you can use to do the create, update, or delete operations. So that's just for making any changes to the database and interacting with the database on our end. Just to give you a quick overview of what this looks like. I mean, this is not a GraphQL tutorial, but this is just a quick view of it. You have a single endpoint, as I said, and then in your payload, you'd have variables, which is basically your query variable. And then in the query, you have the actual GraphQL query, which looks a little bit like this. And here you can see the account, and then the account number and the billing name. And in this case, because it's a query, the account number and the billing name is what we want to have returned. But I could have just said, I just want the account number, and then we would have only returned the account number. Now we need to obviously define on our end what we want to make available in a query like this. And that's where return types come in. And this is where we have another neat integration with Django. So you have your query, and then you want to decide what you want to make available for the caller. And you define that in a type, but with a package called Graphene Django. So Graphene is the normal Python integration with GraphQL. Graphene Django as the Django specific integration, you can define something called a Django object type. And what you can do here is that you just say which model you want to use and which fields you want to use. And that makes it a lot easier rather than defining the whole type from scratch. Just to compare, at the bottom here, you can see what it would look like if you had to define the type from scratch. So you'd have to give it the types. You'd have to say is it a string, as a number, that kind of thing. And you'd also have to tell it where to get it from this object. So the object here is the account, but you need to tell it where to get it from on the account. So using the Django object type, you can imagine it's a lot neater. And especially what I said before, with the idea being that you use a single query to get back all the information you need, you want to be able to return a lot of information. So you don't want to have to write this for every single field on a model. You can use the Django object types to make it a lot easier to return all the information, and it can save you quite a lot of work. Now, the way we use this is by giving our clients the option to use queries to kind of populate the online account. So that's where they can get all the data from Kraken and show it on their online account however they wish. And then they can use mutations to make changes. So for example, to make a payment or to update their payment details or to change a tariff. So we make mutations available for that purpose. So we can do both directions. Another nice thing that we do is that we have this project that we call Blueprint. And this is where we basically have a sample online account that we can give to clients to use. And that uses all those GraphQL queries and mutations that we have available. And they can either just take that and customize it a little bit and use that for their purpose, or they can just see it as an example of how do you use this query, or how can we make use of all this data that we have available, and how can we show it in the most effective way. So I think that's really helpful for someone who's choosing to license our system, that they can build their online account from that really easily. So I hope I've given you a bit of an overview of how we're using Django in all the different contexts. So for customer migrations, where we're using the REST framework to build our APIs and migrate large numbers of customers onto Kraken, and also then how we're using Django configurations, and this is really a key part, how we're using Django configurations to customize Kraken while still having everything in one app. And then finally, how you can use Django integrations with GraphQL to make queries really, really easy to build. So I hope that's been helpful. So where has all this taken us? I spoke at the start about how we went from having a single Kraken instance to then having 9 of them. And this is reflected in the number of households that are onto Kraken at the moment. So we obviously started from very little, and then you could just see the growth of the Octopus energy supplier. But now it's actually gone up pretty rapidly because we've now licensed it to so many other clients, and because we're expanding so much. And this is just the stage that we're at right now. So we're actually contracted to do another 9 million, I think, and we are constantly growing. So it's going up, and there's going to be more challenges, obviously, outside of the ones that I've just addressed. But I think we've got a pretty good handle on it. Going back to the smart tariffs, I explained above, we currently, for Octopus Energy UK, have about 5% of our customers with smart meters on smart tariffs. Now, that might not sound like a lot, but actually, given that they're so new, it's a pretty big number, and the numbers are growing every day. And for example, one of our clients in the UK, Good Energy, they've just launched their own smart tariff. So you can see that they can really make use of our technology and our way of working and our really nice integrations with Django to make this happen. So I hope I've shown you that Django and Kraken make a pretty good team, that having Kraken as a Django app really makes our lives so much easier because there's so many integrations out there, and it's really nice to manage everything in one place and in one system. And I think I hope I illustrated that and gave you a good overview of that. And finally, these are all the places where we're currently hiring. So if this sounds good to anyone, and if you'd like to work on a really big Django app like that with all these interesting challenges that we've got, then please do apply. We'd love to have you. Thank you very much. Yes, okay. If anyone's got any questions, feel free to ask. I think there's still people joining, so we can also wait another minute or two.
To get a bit of an idea on the different, let's say, deliverables. Can I ask you a question? Put them on the timeline.
Sure.
You can hear me? Okay, you can hear me. Okay, that's great. Thanks for the presentation. It's always good to see, let's say, Django used in such a large scale and such global, and all these challenges that has to do with culture and languages and things that are have to be put inside for all these different customers. I was wondering, in terms of security, I think you also have to adhere a lot to kind of local rules like GDPR, things like that. How do you manage, maybe not GDPR, I understand that, but let's say security? Do you have penetration testing, things in place? Do you have regular visits or audits by customers, things like that?
So this is not my area of expertise, but yeah, we do have some penetration testing from time to time. I don't know how often or how regularly. It's sometimes driven by our clients as well, and we have our own security audits, and they sometimes do their own security audits. So there's a few things going around. So I don't know the details myself, but yeah, it's definitely happening. Anyone else have a question?
Thanks a lot for this great talk. I was really impressed to see how you did it. And I think that we can learn a lot here. I'm working for a small startup, so we are not in this, we did not reach this status so far, but I think we can learn, and that's, yeah, thank you.
I mean, we had to learn the hard way as well, right? I mean, obviously you always try and design everything as best as possible, but there's always new things that come up and you have to think of new ways of handling it. But I think hopefully we've done it reasonably well. Otherwise, I'm also just available on Slack as well. If anyone wants to ask, I'm there. I'll be checking back regularly. So if no one has any more questions, I guess we can leave this probably. So shout now if you want to ask a question. Otherwise, yeah, just hit me up on Slack and I can respond there.